Let's get started. I'm sure people are still joining. First off, I want to say we are recording this meeting. It will be put up on our YouTube channel once we get around to it, hopefully within the week. Welcome to the Pipeline Conference event. We're doing some events this year rather than one big conference. I am Franz Andanella Benjamin, the founder of the Pipeline Conference, and I just want to welcome you to this event. We are talking today with Stellar Creative Labs, and they're going to tell us about their USD R&D journey across games, cinematics, and VFX workflows. I'm super excited to hear about this. Our speakers today are Bert van Brande and Fermi Perumal. I hope I got your name right. I'm really bad with that. And Ignacio Urruti. So I want to welcome them and thank them for speaking and telling us about their journey. We're really excited. A couple of other housekeeping things. I just want to let people know we've turned off the audio and video for the webinar attendees. So if you want to speak, message us. And if you had a question at the end, we're going to do the presentation. And then Aaron Tival is going to be giving us being our host today and asking your questions. Just go ahead and put them in the chat and we'll go ahead and have him ask the questions. So we're open for people to ask questions, so go ahead and do that. And please keep your Zoom client on speaker mode versus gallery mode. Maybe that's a note to me. But I want to introduce Fermi and Bert, and go ahead and take it away. Tell us about yourselves. Tell us about Stellar. One last housekeeping. I want to say this group is completely run by our community, and it's completely run by volunteers. And I want to make a special shout out for Dennis Hubbard, as well as Christopher Janney, who's running our Zoom today. And Dennis put these two meetings together, and he's got plans for a meeting in June. So keep an eye out for that. And if you want to help out, ping us, let us know. We're happy, more hands make the work light. So, all right. So thank you. Go ahead and take it over.
Thank you, Fran, and welcome everybody. I'm Bert van Brande. I'm one of the founders of Stellar Creative Lab. And by trade, I'm a VFX supervisor and a CG supervisor and director of technology in a previous life, and a pipeline soup and a pipeline TD actually, although admittedly my coding skills are very rusty. So can you go to the next slide for me? I don't seem to have control over the slides. So just quickly, a Stellar Creative Lab, is an animation studio in Canada, in Vancouver and Toronto, and we do have a presence in Costa Rica, which is our hub to Latin America. And Fermi is here today with us. She's in Vancouver, and Nacho is actually in Argentina. So about 20 years ago, I started as a pipeline supervisor, and one of the companies I worked for, the task was to create a pipeline for CG features. And one of the first tasks there actually was to design and supervise the development of a scene description language and system. And I don't want to go into that much, but I just wanted to say that I know firsthand how much time and effort it takes to create a scene description language and system. And so our immense depth of gratitude goes to Pixar to make this available to the open source community and everybody who contributed to that. So next slide. So yeah, Stellar Creative Lab, we're currently working on Sausage Party Foodtopia series for Amazon, and I'm not going to apologize for that. It's very funny. And we're also working on Marvel What If Season 3 and Marvel Zombies, which is a spin-off of Marvel What If. And above there, you see the previous episodes we worked on, seasons we worked on for What If and Kung Fu Panda for Netflix. And it's quite a variety of high-end animated content. And to support that, we needed a very robust pipeline. And Stellar started 7 years ago. About 2 years ago, we migrated to a USD pipeline or started that migration. So we can go to the next slide. We'll roll the demo reel. And Dennis asked me to keep this PG, so it's not a sausage party. So instead here, this is Marvel What If. And as you can see, it's a CG animated show made to look like 2D animation. So the characters, crowds, some of the effects are all CG animation, and some of the effects, lots of the effects actually are 2D animated, 2D painted. Backgrounds are a combination of painted backgrounds and CG backgrounds with projections, and it's a quite complicated show. And so yeah, we needed a strong pipeline to support this kind of work, the high-end work that we are doing. We're gonna roll it for a minute, but then we're gonna let it go to the next slide. I hear some sound in the background. You can switch off the sound for me. We can go to the next slide. All right, so I'm not going to dwell too much on this, but as you know, I mean, to create these high-end animations, we have quite a vast pipeline spanning lots of departments, and some departments actually using multiple DCCs based on the needs of the show. And we also use different renderers based on the needs of the show. So the Marvel series is lit in Maya, rendered in Arnold. The Sausage Party show is lit in Katana, rendered with RenderMan. So we have a common pipeline, but the pipeline at some point is actually, for me, almost more important than the actual DCCs that are kind of come and go. They plug in as we need them. And you can see in the middle there, we do support still Alembic and FBX, of course, but 2 years ago, we started migrating to USD. Very important for us was our own database, what I call the Interstellar production database, which kept a lot of metadata about all our data, interfaces, and visualizes that data in ShotGrid, where we can also interact with the pipeline from a production management perspective. We can go to the next slide. So if we go back one slide, pipelines are never this bad. I just wanted to make a point, and yeah, you can go to the next slide. I call this the spaghetti junction, and it's like a single connection between every DCC that generates data and every DCC that consumes data. And if we go to the next slide, we are going towards a system where using a standardized OpenUSD data format in the center, you can go to the next slide. It becomes much more efficient and much more fluid. And I apologize for my North American friends, but this is an aerial photo of a roundabout, and it's kind of an intersection mostly in England and Europe. It's a very efficient way to manage traffic and flow, and that's what we do as well, right? We manage flow in our pipelines. And if you just think about it, if we come from, let's say, from the village of Maya and we want to go to the city of Katana, you create this off-ramp and on-ramp. And once you have this system going, the first iteration, the first version that you built, it's going to be a little bit of work. It's not difficult, but it takes time. But once you have those first couple of components to your pipeline, then it becomes really easy to make another off-ramp. Like, for instance, a couple of months ago, we started an off-ramp for Unreal, and we have that working already. So we are currently migrating most of our pipeline components to OpenUSD. And thank you. So yes, for us, why? It's proven technology. We know how much development went to this. As a mid-sized studio, we wouldn't really be able to pull this off ourselves. So the support by the DCCs is growing, and yeah, definitely the common standard makes this very easy to have a common language and to have this interoperability between DCCs, the shareability with other studios, because lots of the productions we work on are complicated, complex, and require sharing with other studios. And shared methodologies, I'm more referring to methodologies in our pipeline for publishing, QCing, reviewing, managing data. And what we're seeing is it reduces our code base, it simplifies our maintenance, and the complexity is being reduced while we see an increased scalability, notably with the environments. That was always a more difficult point to manage with traditional data formats, and that has been a big improvement, including performance improvements, faster load times, faster render times, and also fantastic is the ability to do offline edits, something we already did before, but which we're pushing now, the ability to upgrade assets, update assets, launch things without even opening DCCs, and just do a lot of operations and automate them. And like I mentioned before, with the roundabout, it now becomes easier to integrate and support new DCCs. Like integrating Unreal was fairly easy, and it only required to create that new off-ramp, and now we can have multiple DCCs generate data for that new render for us. All right, I'm gonna give it over to Fermi and Nasho to go more in detail.
All right. Thank you, Bert, for that introduction. Hello, everyone. I'm Fermi Perumal, a pipeline supervisor at Stellar Creative Lab. I'm happy to be here today representing Stellar and talk about the USD work we've been doing, sharing some of the ideas we implemented, some challenges we faced, and what we have in store for the future. So let's get started. Bert already gave us a high-level understanding of Stellar's pipeline. I'd like to start off by highlighting some of the pipeline developments I've seen in Stellar in the past few years. A few of them include integration between editorial and front-end departments like layout and animation, automations with pre-lighting QCs based on certain approval logic, advanced scene builders and propagation tools, asset instance transfer mechanisms between different contexts, also Windows and Linux support for our pipeline software, and lots more. Here's a simplified view of the components that constitute our architecture. There is pipeline compatibility for multiple renderers, as Bert mentioned, that we developed over the years to meet different project demands. The farm rendering system includes the ability to render locally and also on the cloud. Our sync mechanisms, the OS operations, error monitoring tools, and also the event handling systems that we have in place are managed as separate services so that they stay loosely coupled with the rest of our system. All right, so getting to the main topic of the day, USD. USD development has been going on for about 2 years in Stellar alongside our ongoing productions. The core pipeline team, which is our internal dev team, has been the primary developers for integrating USD into our existing frameworks. We've also had involvement from other TDs with specializations in different tool sets to contribute to this work along the way. So shout out to the pipe team for the collaborative effort. The integration process involved finding areas in our pipeline that benefited the most from having less heavier scenes and moving them over one workflow at a time. At this point, we have established USD as the common scene language between 3D packages in our pipeline. As part of our development, we customized USD plugins of different DCCs to compose stages in a way that suits our show structure. So as a result of this effort, we got faster scene assembly, better render times, and also overall better experience for artists who end up using this pipeline. Okay, so that's the introduction, and I'd like to get a bit into the technical details of the USD workflows. So the diagram we see here is the internal composition structure for the common use case of our assets that go from asset development all the way to the short rendering stage. The models get published for different level of detail or LODs. The mid and low LODs are auto-generated from the high LODs. And in terms of look, we switch between a couple of variations. There are viewport-specific look variants to improve playback and specifically for the play blasting process within Maya. So the model, the look, and the cache USDs are then layered during the shot composition stage. So this is a visualization of how different USD layers of character assets get applied to the base geometry layer. The look get published with different possible variations, and the right variant gets applied during shot assembly. It's a pretty cool character from season 2 of What If. All right, diving into it a bit more. This diagram represents the shot composition mechanism with USD layers at the lighting stage. The strength ordering makes sure that the backend overrides take precedence over the front-end layers. So as seen here, on top of the assets geometry layer, we apply the look that includes the shaders and renderer-specific parameters as required. The animated cache USD layer decides the prim's visibility, contains the actual animation data, and variant assignments in context of the shot. We achieved this during the shot setup in Katana by customizing the C++ USD plugin to support multiple overridable layers. We also leveraged USD for crowds in a nifty way by utilizing crowd agents metadata at the rendering stage to randomize crowd variants or apply a certain variant to an agent based on creative requirements. And finally, we apply any overrides that come up later in the game. These overrides prove to be pretty crucial for us because based on the shot size, we perform several optimizations at scene level to improve our render times. So some of the examples could include extended culling, introducing instancing, disabling material bindings, and also, if I had to add, some renderer-based optimizations as well. So as you can see, we have used USD as the data format for not just the static geometry, but also for time-sampled information like character animation, crowds, character effects, and cameras. So we saw this improvement to be evident in one of our newer TV shows yet to be released that Bert mentioned earlier, the Sausage Party Foodtopia. So I'd say, from my experience, I'd say that this show has reaped the most benefits of introducing USD, and we saw a significant decrease in the issues that were reported compared to other shows. And those by issues, I mean in terms of scene assembly in backend departments, or in general, the issues that's caused when packaging and moving caches around between different artists and departments. So we definitely had a lot of happy artists on the show. So in this video, we have the custom importomatic that was built for shot assembly in Katana. The importomatic is context aware and finds the ideal versions for each of the published kind and populates the stage. The node graph is built on the fly with stacked imports and any cleanup nodes as necessary. And as you saw in the video, let me play it again. The metadata from those publishes are available for further computations down the line in the node graph, such as variant results. All right, so that's the implementation part. Now, I would really like to focus on the improvements in our pipeline after we implemented USD. So with the USD's shot composition techniques, we are able to better embrace sequence level workflows. Consider a shot sequence with a large environment as an example. Unlike having to handle the environment setup shot by shot, we create a main environment for the whole sequence. And at the shot level, we are only capturing the edits or customizations that needed in the environment for the shot and based on the position of the camera and the settings. So those customizations could involve pruning out certain elements of camera, tweaking the LODs, or applying overrides to different shot elements. So this shot level USD is now much lighter and also offers the flexibility to make adjustments without having to republish the whole environment. So this flowchart we see here, it's a rough visualization of the edits that happened on a shot level based on the camera transforms. So this is a particularly dense environment called Coney Island in an episode of What If. So as you can see, each shot is undergoing different edits. Yeah, and I thought it would be great to show the amazing final comp results for these shots from the environment that the artist team created. All right. Moving on to the next area where we are able to find benefits of using USD. Since the scene description with USD is DCC agnostic, we use that to our advantage by performing scene manipulations offline as either farm jobs or using standalone tools. So several of the operations I mentioned previously are done this way in our pipeline. So even if they're later in short production, artists have the tools to swap assets or set dress elements based on the creative notes, or even adjust settings after reviewing initial render results. So these are then applied as overrides to existing shot work. This not only saves artist time, this also saves license costs because of the independent operations that we are able to make to USD files without the need of using a DCC and just using our plain USD APIs. All right. I'd also like to shed some light on how USD has benefited pipeline dev itself. So there's a learning curve with getting acquainted for sure with USD. But in the long term, we've seen it benefit the development cycles as well. So we have a common USD API at Stellar that defines stage composition, schemas, metadata, variants, or instancing setups and whatnot. So because of that standardization, making tools that are compatible across DCCs has become easier since the focus is more on the tool itself rather than handling different file formats at the same time. So in other words, USD has helped us define what the entity means, and the definition stays true throughout the pipeline. So this kind of ideology has made integrating new ideas or tools in our system a lot more efficient. And also taking it a step further here, the standardization also stays intact even when we are working with external collaborations. So we often produce content that's a combined effort between different studios, and using a language like USD eliminates the need of coming up with a common language while we share assets between each other. Yeah. So another thing I wanted to cover is the artist perspective of all of this. So we as pipeline, we also have to look at this from an artist side, right? So as to how this integration impacts creative work and existing workflows. So one aspect we were mindful about is to minimize the amount of re-education needed during this migration, while also leveraging the benefits of the technical framework that USD offers, and also making sure that the creative work that's already done doesn't have to be redone or moved through the pipeline all over again. So we resolve this by having an order of preferred publish types for caches while building the scene, so that older asset publishes were still supported. What we also noticed while moving to USD is that the deeper understanding of certain DCC-centric concepts like curves, faces, and other forms of geometry representations become a little obsolete here. So to an extent, I would say that the way USD works, it allows us to forget the technical details of handing off creative data between different teams. So that's what we have. Those are things I wanted to cover for pipeline improvements. And quickly, I would like to talk about the USD and Unreal work we've done at Stellar. So I'm pretty excited to present a sneak peek render of an experiment we've been doing with Unreal 5. So since USD is already integrated in our pipeline, we managed to build a foundational Unreal workflow to render shots within Unreal in a matter of a couple of months. We are still learning from it, but the pipeline currently imports asset effects and camera components as USD and composes them as a stage within Unreal. Also, automations for building level sequencers, sequence level rendering systems, and integration with our production tracking tools are also in place and they're up and running. So this is the first look. All right. So now that I've talked about the implementation and the practical benefits we have seen in our pipeline, we'd like to share our experience with technical challenges we faced and the ongoing R&D work. So for that, I'd like to pass this along to Ignacio Urruti, who's the pipeline core lead at Stellar and has been a key developer for USD. Thanks, everyone. Yes, let me give you the control.
Yeah. Let me know.
Done.
Thanks a lot, Fermi. Hi, everyone. I'm Ignacio Urruti. As Fermi mentioned, I'm the core lead at Stellar. So I'm going to talk about a few challenges that we face. Of course, there are more than this list, but we wanted to share at least some of the key ones that we need to solve during production. So we could say we have two main categories for the type of challenges. One was the technology itself, like how USD was integrated in the DCCs by the plugins that are already provided. And the other big challenge was porting the existing approved assets to USD and getting the same results out from those USD versions. So I'm going to dig into the list just to start talking about them. The no USD composite in Katana. So at that time, we were using Katana 4.5, and the USD plugin didn't provide a way to compose multiple layers and control individual, controlling the path of those layers. So we can change them on the fly dynamically directly inside Katana. And for our pipeline, we wanted to have that control. So the solution was to take ownership of the Katana USD plugin code, modify the USD in node to extend it so we can provide multiple input files. And that way we are able to build the stack of layers directly in Katana. That was a key point for us to start working in Katana directly there and using USD. The second one was USD edits inside DCCs. In this case, we were doing the lighting and rendering in Maya in Arnold. And the lighting artist needed to tweak many shaders that they were inside the USD stage. And the USD Maya plugin doesn't provide a quick way to override multiple nodes parameters in one go. So for that, we end up using the iStanding node. So the iStanding node provides an easy way to select multiple nodes using regular expressions. And was easy for create render layer overrides with that method. So that was the quickest solution we found to move forward in lighting inside Arnold. Then we have the Maya shaders to USD. So as we mentioned, we already were in production. Many assets were approved and they were already being used in PlayBlast. So the client saw those images before, we wanted to maintain the same look even in the Maya viewport. So when porting and publishing to the USD, is some of the materials they are converted automatically to the USD preview material, and the plugin itself doesn't support some color spaces, so we needed to do some post-process after we published the USD version. We needed to open the USD stage and do some tweaking on static colors, and also apply some, create some custom textures with modified color spaces, so we can use them at the end in the viewport. That was a little challenging to find the right way of doing it, and covering many cases because they were using ramps and some custom Maya nodes that we wanted to also keep working. So we needed to bake textures and things like that. So it was a little challenge to keep that. If you start from scratch, it's easier. you prevent all these problems. Then we have the smooth preview. So we have a show that we have very tiny characters and really big sets. And animators, they were struggling getting the contacts, animating the contacts between the ground and the character. So the problem was that USD doesn't provide a smooth preview that Maya provides for normal meshes, Maya meshes. So our solution was to use what we already had set up, what the LOD system, the automatic LOD system. So we provided a way to tag the assets directly before publishing, tag the assets and specify specific subdivisions for some meshes. So when we create the LODs, we also create a super high version, we call it like that, but it's a super high version that was able to be used and swap during animation. For the texture on the previous point, something I didn't mention, we use OpenImage.io for the manipulating the color spaces. And for static colors, we just implemented some quick math. I didn't mention that. And finally, one of the key things that we wanted to keep was the artist without having to learn about USD layers. So something that USD required to store the changes is to select an edit target layer. So if you are in Maya, you need to select which target is the one is going to store all the edits and changes that the artists do. And we want one specific layer, which we call it the cache layer, to be the one that was selected. The problem was Maya doesn't remember that information every time you open the scene. So was very straightforward for us to create a script shop to automatically find the cache layer on all existing USD assets and switch to that to be the edit layer. That was a quick solution. So artists didn't have to open the USD layer editor at all. We were creating everything internally for them. So that was a very clean process for them. So those are just a few of the challenges that we faced. There were much more, of course, but these ones were like kind of big. And on the next slide, I want to talk about some of the dev projects that we have. We are working and testing and playing right now. We have 3 projects going on in parallel. Some are with more progress than others, but we are trying to move forward with the 3 of those. And the first one is the asset resolver. So as we mentioned, we have a system for setting which version is the ideal. So publishers detect those versions automatically, and those are being used for the assembly. With the asset resolver, we will be able to include that process dynamically, and we will prevent from opening the DCCs to update the versions in the existing scenes. We could just go directly to the rendering step and update all the assets versions directly on fly by changing the status of which version is the one we want to be the ideal. We also have sequence locking and episode locking implemented, so we could specify one version to be used and consumed only at one specific sequence. So that's something that will be very important for us. We will skip some processes that we need to do right now. And the other one is we are using Windows and Linux, so being able to manipulate and swap those paths directly on the fly dynamically, that will be something that we will gain from this. And finally, that I'm not entirely sure if it's possible, but it's an idea that we could try to investigate, is to be able to make the asset resolver to be aware of the context, the current shot that is being that is running, and automatically switch to the specific lighting that is being was saved for or published for that shot. So maybe something it could be used in some scenarios. So that's something to investigate. The second one is Material X, is currently being tested by Adam Martinez. He's one of our team members. He already started testing in Maya, Katana, and Houdini, and with Arnold right now. Okay, those are what we are doing right now. We're investigating that. He was able to publish from H2A and load that into Houdini H2A without any problems. Everything was very transparent. That worked perfect. The problem was on Katana side because we needed to use some specific nodes that are provided by Arnold itself, and they are not they don't work in our pipeline because we have a custom USD plugin for Katana. So they need to use the Arnold USD node to load USD files, and we can't use that node. So we need to find another solution. So still investigating how to solve that case. The other big limitation is toon shading. So as you saw on the demo on the reel, we use toon shading a lot, and Material X is not prepared for that yet. I think it's in the backlog, so it's going to be addressed at some point, I hope. One solution will be to write our own definition of the toon shader, but it's not yet something that we have in mind. We are still investigating all the possibilities, but it would be nice to have a global library and for materials and sharing, or doing tools that for building shading networks that can be used in all DCCs. So that will be something similar as what we are doing for USD. And finally, is a web USD viewer that it's at a prototype stage. Is very new. It doesn't have too many features, but the idea is to investigate if we can use a web browser to do the review of assets, provide to the reviewer the possibility to move the camera around and see the shot or the asset from different angles, and leave notes and provide more feedback to the artist. So, Fermi, can you go to the next slide? There is a quick video of the reviewer on the fly. So I'm loading an asset directly there, and it's going to detect automatically from the USD file the frame range and the frames per second. This is it's not our character, but just to show something. And we can do playback. We can move the camera around and play. It's going to play at 60 frames per second, which is the frame rate. And we're gonna store notes for now, and it's gonna remember the frame that the note was made and the camera position. So when you click on one of those notes, it's gonna travel to the camera position of the note, so the artist can see from the same position that the reviewer did the note. And after that, I put some possible features. Can you pause this? So these are some ideas that maybe we can implement and investigate in this viewer, like doing set dressing, moving things around will be nice, loading an entire shot, or loading multiple cameras to see, or even do a comparison between assets. So load multiple assets to see size comparison if it's required. It's still a prototype, of course. So we need to keep working on this. And that's it. I think we covered everything. Sorry if I took too fast. Please ask as many questions as you need.
Thank you. Thank you so much for such a wonderful and information-dense presentation. What you all have done with USD in a relatively short period of time is incredible. We've gotten so many questions in from the audience, and I'm going to start with a fairly open-ended one. which is, what are your top 3 wishes for OpenUSD that would make your life easier? You're allowed to talk amongst yourself.
Sorry. I was reading the questions. Can you repeat them?
Yeah. So, what are your top 3 wishes for OpenUSD that would make your life easier?
I think
Just for all of you, so you don't have to
I
feel.
think we'll all give one. For me, it would be more adaptation from more studios adapting USD as their primary data format. That's the number one for me. Fermi, what's yours?
I think for me, it's what we learned with Material X. So I would hope to start embracing more looked-up workflows within USD. So that would be really good. We are already learning from it as a team. So that's my dream.
Very good. If you can't think of a third, you're not compelled, but there's 3 of you, so it would rank out nicely.
I would say rigging, but I don't think that will be possible. I don't know.
Well, that's an interesting point, because that's something that comes up quite often, is rigging
Yeah.
with USD. So why isn't that possible? What would the path be there to fully round out USD with rigging?
I think the amount of plugins and the way rigging evolved in the way that some riggers, they have their own style. It became like an art in the way we manipulate the nodes and do computations in ways that we didn't expect. So also the variation of plugins that, as I mentioned before, include those in translating. It will be possible to move that to all DCCs.
Yeah, we were discussing this yesterday, and even within Autodesk, between Maya and FBX, not all the deformers or stacks are supported, and the order of evaluation. There's lots of things with rigging that are complicated to resolve. So we started with geometry. We're moving towards looks and materials. I think rigging would be the Valhalla, but we have small hopes.
That will stay probably as the proprietary side of the pipeline with USD for the foreseeable future, I think, then. So we don't have Hasmi with us at the moment, right? But if you had the business production budgeting person in the room with you, and you were thinking about kind of the return on investment, or what the benefits are in maybe cost reductions, overall efficiencies as relates to USD, how would you answer the question of why you should adopt it from the side of the house where things should go faster, be easier, more interoperability, and just generally be cheaper? Is there a way to answer it?
I think so, but it's as you've seen, the shows we're working on are quite complicated, and we need to keep ahead of that game and supporting the ability of creating those complicated shows. And so once we hit a level where we are now efficient at a certain level, the complication rises again, right? Or the complexity of the shows we're doing. So it's our way to stay ahead of the game, to automate as much as possible, like we mentioned, and not even having to open DCCs to upgrade, say, assets within an environment that is a complex, multi-level environment with hundreds or thousands of assets. It saves us time, it saves us man hours, it makes things more efficient. That's our couple of the reasons that we can use to talk with people that are more interested in that part of the business.
Mm-hmm. With LODs were mentioned a few times today. There was a question that came up earlier about if these were used for guide purposes with the viewport to help you maybe faster with as proxies, or if that's the case, why maybe purpose proxy render guide wasn't used, or just generally if you could describe your use of LODs in your workflow.
Fermi, I can answer. Okay. So yeah, if you look at the slide about showing the LODs, you can see that it says a variant or purpose. We had that in mind of using the purpose, but because we were already working with variants, we have some tooling for variants already. We decided why not just keep using variants, and also for the artists, less tooling is better. So I think that was the main decision.
Okay. Have you done custom schemas in USD for things like defining wind or similar things that are not standardized in USD yet? So how do you handle that now? You're just setting up some dynamic attribute within whichever content software that you're using on a per software basis, I guess. Yeah. Okay. How did you manage getting third-party studios on board with your USD efforts? What was that conversation like?
Yeah, that's an interesting question, and that was not totally successful. We had a show where we needed to share assets, and we had to go back to sharing Maya files and more traditional formats. Not everybody was ready yet, so that's definitely the hope for the future, that using a common language, a common data format, makes it easier to share with studios, even if they're using different TCCs on the front or the back end of it. Because yeah, we definitely are seeing sometimes shows where we get assets that were made with 3D Studio Max and then other assets made with Maya, render with Arnold, with Redshift. So that's definitely the hope that in the next couple of years we see the standardization take a hold in the industry.
Yeah, very good. Do you think that you could approximately quantify, maybe especially for studios who are thinking about USD but haven't adopted yet, what the work is involved in creating the tooling to make those workflows possible? How many developers would be needed, time taken to get the pipeline up and running? You could use your own as an example, or what you would recommend to others.
I'm going to start and then let Fermi and Nashu take over. I think we started with kind of a limited scope or ambition. We started with tackling the environments, because that was where we had a robust Alembic character caching pipeline. We had our own database kind of acting as the scene description. So we were sat there, and once we saw the advantages we were getting from the using USD for our environment caching and data format, the pipeline started, the USD pipeline started to grow within Stellar. And that first section took a couple, maybe 3-4 months. And then it started to growing from there, and now including things like crowd characters. But yeah, I think I'm going to let Fermi and Ashu,
Right. Yeah. To add to that, like Bert mentioned, it was initially integrated as optimizations in the front end of the pipeline, but then we also had a sausage party ongoing. So we used that. Our development actually went hand in hand with the production itself. So when there were requirements for making animation tools or moving them over shot building tools, you leverage that to build tools that supports USD, and we were able to test them and integrate them into the pipeline. So our core team is 3 people, but it's a combined effort between different departments, because different TDs have different specializations. So we get them involved. We made that part of the pipeline, and then we integrated it. So it's overall, I would say it's definitely a smaller team, and it took us 2 years to get to running a one TV show with USD integrations.
So something technical. I think it's important to. I think we abstracted to the idea of having one stage for everything, to have one stage per asset. That became much easier to handle, because you just build the asset and you don't have to worry about what is changing how you trying to keep everything and tracking everything in one stage. So moving to one stage per asset was key. Katana became the problem because Katana wants one stage file kind of saying. So that's why we pushed to get the USD plugin in Katana modified. And another key point, I think, is trying to abstract the idea of what is an asset in your pipeline, and from there build a framework that then can be used later for tooling. Because that's going to make things for other developers. They don't have to learn USD because they see a class and the class definition, oh, I need to load the cache. I need to load, and they have something that is load cache. Simplify the work for other developers that they are not aware of USD. That's another key point. So you get more hands playing with USD without knowing USD.
Yeah, makes sense. There's a popular question in the chat around your workflow with RenderMan, and the question is, what workflow did you come up with for shading and lighting with USD inside Maya using RenderMan, or do you do that outside of Maya?
So can you repeat the question, please?
Yes, I'm sorry, Bert, go ahead.
No, well, the answer is we did this in Katana, not in
Katana.
Maya. And currently we use the Katana look file as a methodology, which is what we're looking at moving over to Material X, so we can share the looks between Maya, Katana, and so forth. So, but I think, yeah, that's the answer mostly. Any more technical details for me or Nasho?
No, I mean, our show, based on our show's requirements, we use RenderMan along with Katana. So I wouldn't say we actually battled and we moved out of Maya. We didn't really spend time within Maya because our lighting systems were built in Katana. So our USD plugin was customized to be able to layer the Katana look file as well when building the shot assembly. So
Do you have maybe I don't want to make you answer this if you don't want to, but do you have a preference? But if you were to use one or the other?
You mean between Maya and Katana, or between
Maya for your lighting and rendering setups? Yeah.
Katana.
Yeah, I think Katana is very efficient for lighters. It's a very natural way of thinking of lighting. I call it a flow of consciousness. It's how we just think about importing a scene, applying the looks, and so forth. But we also know that the Foundry is working on making USD more of a part of the core of Katana. And on the other hand, the Marvel shows we're doing, we are lighting those in Maya because it's a different requirement. The look there is actually not achieved as much in Maya and during lighting but more during compositing in Nuke. So the shows are completely different in style and in requirement of the final art, the final image we're creating. So we're using different tools for those.
Yeah. On a maybe more under the covers technical note, are there any lessons about the asset resolvers in terms of disk I/O? Are you using the artist machine level caching apart from solutions like Avir, or are you optimizing the resolver heavily? There was a mouthful of a question that came in.
I'm reading it, but to be honest, we are starting with the idea of the asset resolver and investigating. So we are aware of caching. We know that can be a problem on how we set up that, because the amount of queries that you can end up getting can be very high. So yeah, to be honest, Ashish, I think if we found a solution, I can contact you and send you what we found out.
When I hear questions like that, because you talked about how you use both VMs and do work locally, and I think about the cost of egress and keeping things cached locally and in your virtual environment. How much of a consideration is that for you? Do you have to do anything special architecturally to not incur, bonus cost of moving things out of the cloud when you're working that way?
We're currently, when we are rendering in the cloud, we're making this part of our network. We're creating a virtual network with a cloud render provider. So we're not dealing with egress at this point.
Excellent. So we're a few minutes out from the end here, and I know that you all have been monitoring some of the questions that have come in through the chat as well. Were there any that you wanted to pull from the stack and answer that we haven't talked about already? I'll give you a minute to look at those. And while you're looking at that, yeah, go ahead.
Oh, I can briefly talk about the question about importing and exporting particle animation to game engines. So in terms of, I know we didn't speak too much about the FX part, but
We're coming to the end. We just have a couple of minutes.
Yep.
Okay, sounds good.
We're good.
I'll be quick. So I would say for the show that I talked about where we have the most integration, the reason why we couldn't move all our FX into USD is mostly because of time, I would say, project deadlines. But we did have a learning experience there. So we know that USD supports particles, instancing, and rigid body dynamics. So it's a matter of time to be able to set that up in our pipeline and get it running. So I wouldn't say it's the same case for our other for our other shows, because some of our Maya workflows are tightly coupled with the shaders, and moving it from Maya into DCC like Houdini and then moving it back, there's a lot of overhead there. So it's something that we would be untangling it and spending time on to figuring that out by working from the foundation. So that's something I wanted to mention here.
There's a couple of people from Stellar putting some notes in the chat, lighting with Katana. They definitely loved it.
Yeah, our pipe soup, our lighting soup agrees.
I saw that.
Yes.
We'll make sure that your A&M colleagues get their chance to play with Katana more, since they've been mostly in Maya, but it's come up. Well, thank you all so much for being here and doing this talk today. There was an overwhelming amount of information. I think everybody's taking away lots of new and interesting and useful things from this. I'll sign off and let you all make any closing notes. And thank you to the Pipeline Conference and the volunteers. It's an all volunteer effort, and so glad to be a part of it. And thank you.
Thank you, Aaron.
Yeah.
I just want to close with studios that are considering moving to USD. It's probably easier than you think, and it's probably going to take a little bit more time than you think. But once you get going, it becomes much easier.
Thank you, everyone, for coming. And we're, like we said before, we're going to have another meeting in June. So keep an eye out for that. And we're definitely going to do an event, not a day event, but an event at SIGGRAPH in Denver, along with the Cloud Native people. So thank you all for coming, and thank you for speaking.